One morning in France in 1885, a dog attacked 9-year-old Joseph Meister, biting him in 14 places. He survived, but his mother realized he was probably now infected with rabies, an almost certain death sentence. She rushed him to Paris, knowing his life depended on a rumored experimental medicine. Today, without proper intervention, rabies remains deadly in almost all cases, making it the most lethal infectious disease. However, modern advances have afforded us a much deeper understanding of the mechanisms that make rabies so dangerous and treatment-resistant, and have revealed the best methods to save lives. Rabies is caused by the roughly 20 virus species in the Lyssavirus genus, all of which attack the mammalian nervous system. Lyssavirus rabies, the most abundant, can infect any mammal. Lyssaviruses mainly persist long-term in bat populations. Besides bats, rabies virus has also adapted to carnivores like foxes, raccoons, and skunks. And most human rabies infections come from dogs. Infection begins with the transfer of virus-laden saliva into the new host's tissue. This could happen with a deep bite wound or a simple lick to certain spots. Once inside its new host, the virus particles, called virions, set out for the brain. If the infection site is closer to the head, things may escalate faster. Rabies virions may lay low for days, weeks, months, or in rare cases, years, replicating without causing any immediate symptoms. Virions also suppress certain immune responses, making it harder to clear an infection locally. Meanwhile, the virions begin to travel, entering local nerve cells and exploiting the existing transport mechanisms along their axons, traveling up to 100 millimeters a day. Their protected position here in the nerve cells helps shield the virions from the host's immune system. Once they've made it to the central nervous system, the infection enters a new, devastating stage. Clinical symptoms develop as rabies virions rapidly proliferate, spreading into the peripheral nervous system and its connected tissues. First, the escalating infection registers with flu-like symptoms, where a different neurological infection might cause inflammation that opens the blood-brain barrier and incites an immune response. Rabies viruses do not, so immune cells and therapies cannot easily or quickly reach them there. Then, as the disease damages the nervous system, things take one of two turns. In paralytic rabies, symptoms like a vacant expression, weakness, and paralysis set in. Furious rabies, meanwhile, is associated with hyperactivity, uncontrolled movements, hallucinations, aggression, and paralysis. As virions accumulate in the salivary glands, the host secretes excess saliva. The infection also often causes hydrophobia in people, where throat spasms make swallowing water painful and difficult, further concentrating the virus in the saliva and increasing the odds of transmission. Some hosts are especially effective at transmitting the virus. Humans, however, aren't, and rarely transmit rabies themselves, for example, in cases of tissue or organ transplantation. Regardless of whether transmission occurs, this period of acute illness is almost always followed by coma and death. Once symptoms have begun, there is currently no cure for rabies. However, we do have highly effective preventative methods if they're delivered early enough, and Joseph Meister was the first to benefit. For years, French scientist Louis Pasteur and colleagues had been trying to develop a rabies vaccine. They collected the spinal cords of rabies virus-infected rabbits, dried them to weaken the virus, and injected the resulting mixtures into dogs and other animals. Meister's mother got him to Pasteur 2 days after the attack. He received a course of inoculations, and though the procedure was risky, he beat the odds, becoming the first rabies-vaccinated person to survive. Today, 2 series of vaccinations are available: pre- and post-exposure prophylaxis. Each is highly effective at preventing rabies virus infections from reaching the central nervous system before symptoms develop and the virus has done irreparable harm. The very few people known to have survived rabies after the onset of symptoms have done so due to intensive care, usually sustaining neurological damage in the process. Around 59,000 people are still estimated to die of rabies annually, though the number is sadly suspected to be higher due to insufficient medical access in rabies-burdened areas. Scientists are still looking into new therapies, but the way rabies virions elude the immune system and damage cells makes the infection extremely difficult to treat. And because the lyssavirus has so many natural hosts, it's impossible to eradicate the disease. This makes preventative measures especially essential. Even unconfirmed, potential exposures, like the mere presence of a bat in one's house while they've been sleeping, warrant serious medical investigation. Do you ever feel like you don't know enough about your own body? Subscribe to this channel to learn about everything from baldness to muscle growth to why we have hair in such random places. Stay tuned and stay curious.